Gut, ich möchte gerne Herrn Professor Afrin ankündigen. Er ist der sozusagen Wegbereiter im Bereich des MCAS, M-Case auf Englisch. Und ich freue mich ganz sehr, dass wir heute einen State-of-the-Art-Vortrag von ihm hören können. Und ich denke, wir beginnen auch, ja?
It is my pleasure to introduce Professor Afrin from New York as one of our keynote speakers on the topic, and I quote, Involvement of mast cells in modern life, physiology and pathophysiology. Professor Afrin is an MD, Professor of Medicine with subspecializations in hematology and oncology. He lives and works in New York, USA, and is one of the leading experts on mast cell activation syndrome. He published numerous articles on this topic, including a book, Never Bet Against Occam, Mast cell activation disease and the modern epidemics of chronic illness and medical complexity. And without further ado, Professor Afrin.
Thank you very much, Lisa. Very much appreciate the opportunity to deliver this talk at the occasion of the 10th anniversary of the VAEM. Like to start by noting that we'll be talking just at a very high level about normal mast cell physiology and mast cell disorders. I have no conflicts of interest to disclose. With regard to normal mast cell physiology, let's start by pointing out that the mast cell descends from the hematopoietic stem cell. And I think it's worth noting that the mast cell actually was the very first host defense cell to emerge as multicellular or eukaryotic life began emerging a bit more than 500 million years ago. Over time, all of the other host defense cells that you see arrayed here began emerging, each of them serving various specific defense functions more efficiently and effectively than the mast cell. But nevertheless, the mast cell back in the beginning was the only defense cell. It had to acquire, of course, a vast array of molecular weapons and other tricks to defend the multicellular organism to survive to the next generation. And fast forward 500 million years, and the mast cell is still present, certainly in much smaller numbers than these other types of cells that are more effective at defense. But the mast cell is still here. It still has all of its weapons. And as long as those weapons are deployed appropriately, that's to our benefit. But with so many weapons at its command, it should be no surprise that when the mast cell begins malfunctioning, the inappropriate deployment of these weapons can lead to a vast array of problems. A few other quick points about normal mast cell physiology. Again, these cells descend from the hematopoietic stem cell in the marrow. They fairly quickly leave the marrow and actually transit only briefly through the peripheral blood before exiting into various peripheral tissues to complete their maturation. They're pretty sparsely distributed in most tissues in the body. Where they are dominantly sited is at the environmental interfaces and adjacent to all vessels and nerves, and this is what permits them to best perform their principal role in human biology and host defense. Lymphocytes, for example, require hours to activate when threatened. Neutrophils require minutes to activate. The mast cell activates in sub-second time. The mast cell's principal role is to synthesize various active substances that we generically call mediators, and to release various subsets of those mediators upon various types of triggerings or assaults upon the body. I think it's important, too, to understand that normal numbers of normally functioning KIT, the tyrosine kinase receptor on the surface of the mast cell that is the dominant mast cell regulatory element. Normal numbers of normally functioning KIT are critical for many mast cell functions, including survival and activation. And actually, there's tenfold more copies of KIT on the surface of the mast cell than just about any other type of human cell. Just to illustrate in a rather oversimplified way what's happening when KIT gets activated, you can see here that the normal ligand of stem cell factor binds to a homodimer of KIT. And when this binding occurs, this leads to immediate conformational change in the intracellular domain of KIT. And this conformational change or activation of KIT immediately leads to the activation of a wide range of other downstream pathways, such as the JAK-STAT pathway, the RAS-MAC-ERK pathway, and many other pathways which lead to the survival and the activation of the mast cell, the production and the release of various mast cell mediators. We all learn in our training the classic, the so-called classic method of activation of the mast cell, by which polyvalent antigen cross-links adjacent high-affinity antigen-specific IgE molecules which have been pre-bound to IgE receptors on the surface of the mast cell. But there's a vast array of other mechanisms, too, by which the mast cell can be activated. A variety of physical stimuli can activate the mast cell, as well as a vast array of other chemoreceptors. Actually, more than 250 receptors have now been identified on the surface of the mast cell, including, of course, a large array of the toll-like receptors, which confers upon the mast cell the ability to recognize various microbial assaults. Courtesy of Dr. Theo Harris at Tufts University, this 3D video microscopy will illustrate quite well just how rapidly the mast cell activates and releases its mediators when a single molecule of a trigger, such as substance P, comes to engage a substance P receptor on the surface of the mast cell. And you see here this immediate degranulation of the mast cell, this almost explosive outpocketing of the mast cell, releasing all the mediators that had been pre-stored in those mediators. So the mast cell is capable of synthesizing and releasing a vast array of mediators. Actually, more than 1,000 mediators have now been documented to be products of the mast cell. And I'll entertain you at the bottom of the screen here for the rest of this presentation with a list of all these mediators. What you see on this page here in a font almost too small to read is just a tiny subset of the vast range of mediators that are produced by the mast cell. The point being that even though we're taught in our training these cells principally produce tryptase and histamine, in truth, what they're actually doing extends far, far, far beyond just tryptase and histamine production. Now, let's switch from normal mast cell physiology to the mast cell disorders, starting with the mast cell disorders we've long known about. Of course, the allergic diseases are the dominant form of the mast cell disorders. These are actually now known to be present in about 10 to 20% of the world population. The incidence and prevalence of these diseases has been steadily increasing in the last several decades for unclear reasons. A number of hypotheses out there, but nothing proven yet. We know that the allergic diseases are driven by a variety of genetic and environmental factors, but fortunately, there's relatively little mortality from these diseases, but there's no denying that there can be significant quality of life effects from these disorders for the duration of the patient's life. Now let's switch from the very common allergic disorders to the quite rare disorder of mastocytosis, first discovered in its dominant cutaneous form of urticaria pigmentosa in 1869 by one of your countrymen. It took another decade before the mast cell itself was also discovered by one of your countrymen. And another decade before it was recognized that urticaria pigmentosa actually is a malignancy of the mast cell. Another half century before we began realizing that the mast cell can cause internal disease, and that's about the time when we began recognizing all of the various mediators produced by the mast cell. In time, we began classifying the different forms of mastocytosis, and in the mid-90s is when we first identified the KIT D816V mutation that is present in almost all cases of mastocytosis, and we also identified a flow cytometric signature that uniquely uniquely identifies mastocytosis. In 2001, the World Health Organization came out with its classification system for mastocytosis, and that's the system we've been using ever since for mastocytosis. And coincidentally, that year was also the year that the wonder drug for chronic myelogenous leukemia, imatinib, first emerged. And it didn't take long before it was realized that imatinib actually works spectacularly well on the ultra-rare cases of mastocytosis, which do not feature the codon 816 mutation in KIT. In the last 20 years or so, it's become increasingly apparent that the cancerous overproliferation, the neoplasia of the mast cells in mastocytosis, actually causes clinical problems in only the rarest, most aggressive forms of mastocytosis. It's actually the inappropriate activation, the inappropriate production and release of various mast cell mediators by these dysfunctional mast cells. That's what's causing the vast bulk of the symptoms in mastocytosis. So this was the landscape of mast cell disease we used to know about, a mountain of disease. This is not drawn to scale, but essentially the vast bulk of the mountain were the allergic disorders, and the tiniest tip of the mountain was mastocytosis in its various forms. Cutaneous mastocytosis, much more common in children and occurring about tenfold more commonly than systemic mastocytosis, much more commonly seen in adults. But the entire mountain features inappropriate activation of the dysfunctional mast cells, whereas it's only this tiny tip of the mountain that additionally features cancerous proliferation of the mast cell. Now let's switch to the topic of mast cell activation disease. Actually, it was back in the mid-1980s that it was first published, first hypothesized in print that a disease of inappropriate activation of the mast cells without the accompanying neoplasia defining mastocytosis ought to exist. But it took another 20 years or so before we saw the first case reports of MCAS get published. And that was also the time when one of your countrymen, Dr. Gert Molderings at the University Hospital of Bonn, and his colleagues began identifying that most MCAS patients actually have a wide variety of mutations in KIT in their dysfunctional mast cells. It's just that it's almost never the codon 816 in KIT that is mutated in MCAS. And in the ensuing years, it became apparent that most MCAS patients and mastocytosis patients, for that matter, also have a wide variety of other mast cell regulatory gene mutations as well, beyond just in KIT. It was in 2010 that we saw the first paper proposing a change in terminology in this area of disease, switching from mast cell disease to mast cell activation disease, on the new recognition that it really is the activation that is driving most of the clinical problems in this area. And that paper included the first proposal for specific diagnostic criteria for mast cell activation syndrome. But there were a number of problems with that proposal. So an alternative proposal emerged in the literature just a few months later from, again, the investigators in Bonn, as well as myself. These various proposals have been revised over the ensuing decade. The original proposal has come to be known by some as the Consensus 1 proposal. The alternative proposal, which takes a somewhat broader view of the disease, has come to be known by some as the Consensus 2 proposal. The WHO last revised its diagnostic criteria for mastocytosis in 2016, but recognizing the controversies regarding these different sets of diagnostic criteria for MCAS, they fairly wisely made no statement at the time regarding diagnostic criteria for MCAS. So this is the new understanding of the landscape of mast cell disease. The previously recognized mountain is now seen to itself be merely the tip of a vastly greater iceberg of mast cell disease. It's above this waterline, so to speak, of fairly easy clinical recognizability that we find the mast cell disorders we previously recognized. But submerged below this waterline is this vastly greater array of mast cell activation syndromes that we have not really learned very well yet how to distinguish among them. Nevertheless, the entire iceberg features inappropriate activation of the mast cell, whereas it's just the tip of the iceberg that features the neoplasia defining mastocytosis. Originally, it was thought that MCAS was, at least it was thought by some originally, that MCAS might be as rare as mastocytosis, but more recently it's come to be appreciated by many that MCAS is quite prevalent, perhaps as much as 17 or even in more recent estimates, up to 20% of the general first world population. And in the last quarter century, it's become increasingly evident that mast cells are critically involved in the development of a vast array of chronic multi-system inflammatory diseases. And now that we've been getting a better understanding of the prevalence of MCAS and its biological underpinnings, the question arises as to what portions of the populations of the patients bearing each of these chronic inflammatory diseases might actually have those diseases rooted in various in assorted clonal variants of mast cell activation syndrome. So that's going to require a lot more research to pin down. So again, we think this disease is clonal in most cases. More than 50 mutations have now been identified in various MCAS patients scattered across all domains of KIT. We know that most of these patients have multiple mutations in KIT and other mast cell regulatory genes, but it's frustrating on the clinical front lines that we don't have commercially available assays yet for most of these mutations. This just very briefly illustrates some of the mutations found littered across all domains of KIT. But to answer the question as to how this one disease, so to speak, mast cell activation syndrome, can present with such extraordinary heterogeneity and such confusing and confounding heterogeneity at the clinical front lines, one simply has to do the biology math. We know that mast cells produce and release not just scores, but actually hundreds of mediators. And we know that any one activating mutation is going to lead to the abnormal constitutive and reactive release of multiple mediators, creating some potential for multi-system illness and heterogeneity among patients. But it gets a lot more complicated than just one mutation, because we know most of these patients have multiple mutations in KIT, leading to even more potential for multi-system illness and heterogeneity. But it gets more complicated than that because most of these patients have mutations not just in KIT, but in multiple other regulatory genes in their mast cells. And to be clear, most of these mutations are somatic or acquired mutations rather than inherited mutations. But it gets even more complicated than this because we know that each mediator that gets released has not just one effect, but actually a huge and unique array of direct and indirect, local and remote, acute and chronic effects. And so it becomes evident that it's the particular mutational profile, the particular acquired mutational profile in the individual patient's dysfunctional mast cells that leads to the particular pattern of abnormal constitutive and reactive mediator release in that patient that leads to the particular clinical profile seen in that patient. In general, at a very high level, the disease presents with chronic multi-system illness of general themes that follow along the effects of the mediators. So inflammation is the universal constant in MCAS because of all of the inflammatory mediators produced by the mast cell. Another theme here is the allergic type phenomenon. I say plus minus here because there are plenty of mast cell activation syndrome patients who don't have any allergy to them, and other unfortunate individuals who are in round-the-clock anaphylaxis. And everybody else with MCAS is somewhere in between those two polar opposite ends of the allergy spectrum. The final theme here is the hardest to clinically recognize because these clinical effects emerge the slowest. That is the abnormalities in growth and development that can occur in any tissue in the body as a result of many of the mast cell mediators being integrally involved in guiding growth and development in the various tissues in the body. The disease typically begins first manifesting symptoms no later than adolescence, quite often even earlier in childhood, occasionally even in infancy. But because most of our profession still is not aware of the disease, it typically goes unrecognized for decades, even the patient's entire life. Nevertheless, throughout the course of the patient's lifetime, even though the disease is constantly waxing and waning in its clinical activity to some degree, it waxes and wanes about a fairly stable baseline for long periods of time. But then from time to time throughout a mast cell patient's life, the disease can significantly escalate the baseline level of misbehavior in the dysfunctional mast cells. And these escalations typically shortly follow by anywhere from a few days to at most a few months, a major physical or psychological stressor. It's not to say that every stressor will escalate the disease, but major stressors definitely have potential to significantly and permanently escalate the misbehavior of the disease. It's almost always multi-system. It has a perplexingly and constant course, and one of the confounders in clinically recognizing it is that externally these patients often appear normal and healthy while internally feeling quite poorly in a huge variety of ways. It's important, too, to understand that although we used to think that tryptase was a good marker for mast cell activation, we now recognize that what it's principally marking for is the total number of mast cells in the patient's body, the total mast cell load. So with mastocytosis, you fairly reliably have a significantly elevated tryptase level, whereas with activation, tryptase often acutely rises in anaphylaxis, but in other forms of activation, tryptase is not a very reliable marker of activation, and instead, in most mast cell patients, most mast cell activation syndrome patients, we have to go looking for elevated levels of other mediators that are relatively specific to the mast cell, such as the heparin and chromogranin A and prostaglandin D2 and histamine and leukotriene E4 that are listed here. But it is quite challenging to accurately measure the levels of these mediators for a variety of reasons. Unsurprisingly, these patients wind up seeing a vast array of doctors over the years. They acquire long lists of superficially described problems. They often come to be thought by their doctors and others as psychosomatic, and put yourself in their shoes. If you've been seeking diagnostic answers for your clinical problems for so long and you can't find good answers and effective treatments, then you just stop telling people about your problems. You just learn to live with them. So it becomes very important for the physician who comes to suspect MCAS in a given patient to take a very thorough review of systems to extract from the patient the symptoms the patient long ago stopped reporting. At a very high level, the diagnostic workup at present for this disease is to first establish suspicion that the patient might have the disease. And of course, one has to know the disease exists to establish suspicion. Also helping to establish suspicion, the good folks, the investigators at Bond, have developed a validated checklist of symptoms and other parameters in mast cell activation syndrome that can help identify patients as likely having MCAS. After suspicion is established, one pursues initial testing, and this often can be as simple as just checking a tryptase level to determine whether the patient needs to be further evaluated for the rare disease of mastocytosis. And then beyond that, mastocytosis is rare, MCAS is common, so most of these patients then have to go on to the much more challenging step of testing the various other mast cell mediators listed at the bottom here. The prognosis for indolent mastocytosis, which comprises the great majority of systemic mastocytosis cases, as well as for cutaneous mastocytosis and for mast cell activation syndrome, is actually fairly good. Most of these patients seem to live a normal lifespan. And therefore, as noted at the bottom here, given that most of these patients will live a normal lifespan, the improved quality of life that they can achieve once correctly diagnosed becomes obviously very important. Treatment, again, I don't have the time to go into detail, but at a very high level, yes, we still use cytotoxic chemotherapy and newer KIT inhibitors to address the ultra-aggressive forms of mastocytosis. But for the more indolent forms of mastocytosis and MCAS, the clinical problems all relate to the inappropriate activation of the mast cell, and we don't need cytoreductive treatments for that. Instead, we want to try to identify and avoid the patient's triggers as best as possible, inhibit the production, the aberrant production and release of mast cell mediators. We want to block the actions of the mediators whose release we could not prevent. We occasionally use ultraviolet phototherapy for advanced cases of cutaneous mastocytosis. And finally, let's not forget we need to concurrently treat the secondary issues and comorbidities that arise from the activation we could not control. There's a vast array of research opportunities that can occupy an army of researchers for decades, if not centuries to come in this area. Don't really have more time to go into all of this. And I'll just say in general, where we principally need to focus is in improving our diagnostic techniques, hopefully switching from the difficult measurement of the mast cell mediators to the somewhat easier genetic assessments for the disease. We need to better understand the etiology of the disease and certainly get better at predicting which of the many treatments which have already been found helpful in various mast cell patients, but we need to get much better at predicting which specific treatments will best help the individual patient with his or her specific variant of this highly variable disease. Just in summary, again, tryptase, the tryptase level dominantly reflects mast cell load, not the activation state. And we need to understand most of the symptoms in this disease come from the inappropriate activation of the mast cells, not the number of mast cells. And most of these patients will survive a normal lifespan, making identification and control of the disease much more important to give these patients a better quality of life for decades to come. I'll stop at that point, be happy to take questions, and let me again congratulate the Society on its 10th anniversary, and I very much appreciate this opportunity.